Lesson 3 in Chapter 7 deals with square root functions. We'll be graphing, we'll be using square root functions to solve word problems. It's going to be lovely. When we graph square root functions, they look like this. Not specifically like these people, but a little bit like their arms. Square root functions have a definite endpoint, and then they continue on forever in kind of a half parabola to the side. So a definite endpoint and a half parabola to the side. A definite endpoint, half parabola to the side. On this girl that's stretching, her armpit is the endpoint. Her hand is the arrow that goes on forever. And notice that she can actually go the other way as well. Her armpit still being the endpoint. Her hand still being the arrow out to the side. Square roots can also, usually if they're a negative function, again, armpit is the endpoint, hand is the arrow, and it's half a parabola going one way. Just like before, it could go the other way. Armpit, still the endpoint, hand, still the arrow. So your graphs should look like this. Square root functions are the inverse of quadratic functions. That's why they look like parabolas. The inverse of a quadratic function is a square root function only if the range is restricted to non-negative numbers. Because if we have negative numbers underneath that square root, you and I both know we end up with i's, complex numbers. And even though they're lots of fun to sing about, graphing them is not so fun. So we need to restrict things to non-negative numbers. In your assignment, you'll get problems like this. Graph y equals the square root of 3x plus 4. State the domain and range of the function. Now normally only Marvin has to do the domain and range, but today everyone does. And that's actually where we're going to start today. We said that underneath the square root couldn't be 0, so we know that 3x plus 4 has to be greater than or equal to 0. Solve for x by subtracting 4, 3x greater than or equal to negative 4, divided by 3. So x has to be greater than or equal to negative 4/3. That's our domain. The next step is to make an xy table. The very first number at the top of your x column is going to be that negative 4/3. And then we're going to choose numbers, because they have to be greater than that, we're going to choose numbers that are larger than that. Just a couple is fine. Then we start plugging those values in to our equation. Square root 3 negative 4/3 plus 4. 3 times negative 4/3, the 3's cancel. Negative 4 plus 4 is 0. Square root of 0 is 0. Perfect. If we plug 1 in there, 3 times negative 1 plus 4. 3 times negative 1 is negative 3 plus 4 is 1. The square root of 1 is 1. If we put a 0 in there, 3 times 0 plus 4. 3 times 0 is 0. Plus 4 would be 4. Square root of 4 is 2. If we put a 1 in there, 3 times 1 plus 4. We get 3 plus 4. We get the square root of 7. And then we put a 2 in there, 3 times 2 plus 4. 3 times 2 is 6, plus 4 is 10. So we get root 10. Now, if you're not for sure on these square roots, you can go ahead and convert them to decimals. Using my calculator, I know that the square root of 7 is 2.6. I know the square root of 10 is 3.2. So now I've made my nice XY table. And because I actually need to graph, I'm going to erase my work over here. But I've got my nice XY table. I'm going to start plotting points. Negative 4/3 0 is about right here. Negative 1 positive 1 is here. 0, 2, 1, 2.6, 2, 3.2. We've got a nice set of points. This top point, that's my end point or armpit. From there, looks like we're stretching over to the right. We've got a graph that we know looks like it's supposed to. We've got our domain. The last thing we need is our range. Remember, range deals with our y values. All you have to do is look at your y column. Put a y, put the first number in the column 0, and then you think, what happens? As we go down the column, the numbers get larger, so our y values have to be greater than or equal to 0. Here's our domain, here's our range, here's our graph. That's what you're going to be doing through most of the assignment today. All right, let's try this process again. We've got a new equation, y equals the square root of 3x minus 6 plus 4. We need the domain and the range, and we need to graph it. Our first step, we know that underneath the square root cannot be negative. So 3x minus 6 has to be greater than or equal to 0. Solve for x, 3x greater than or equal to 6, divide by 3, so x has to be greater than or equal to 2. That's our domain. We use that domain to make our table. Remember, the first one is that number. And because x has to be greater than or equal to 2, we're going to choose a few more numbers that are greater than 2. From here, we have to do some math. We need to plug some numbers in, and we plug it into this whole equation. You'll notice that when I found the domain, I just used the numbers underneath the square root. When I make my table, I have to use the whole thing. So the square root of 3 times 2 minus 6 plus 4. I get 6 minus 6, or 0. Square root of 0 is 0, plus 4 is 4. And I do it again. 3 times 3 minus 6. 3 times 3 is 9, minus 6 is 3. And using my calculator, I know the square root of 3 is 1.7. 1.7 plus 4 would be 5.7. I do it again. Square root of 3 times 4 minus 6. I get 12 minus 6, or the square root of 6. And using my calculator, I know the square root of 6 is 2.4. And just like before, I have to add 4 to that, so I get 6.4. And one last time, square root of 3 times 5 minus 6 plus 4. 3 times 5 is 15. 15 minus 6 is 9. Square root of 9, I don't have to use my calculator for that. I know it's 3. Plus 4 is 7. Once you have your table sorted with quite a few numbers in there, you can go ahead and graph it. Plotting points. Over 2 up 4. Over 3 up 5.7. Over 4 up 6.4. Over 5 up 7. And you'll find that that first initial ordered pair, that's your armpit. And the rest of them just stretch over that way. So now we've got the domain, we've got the graph, we need the range. Remember, the range deals with your y values, and you're going to use that very first number. So we know there's some relationship between y and 4. As you look down the column, you realize all those numbers are larger than 4, so y is greater than or equal to 4. We've got our domain and our range. We've got our graph. We're all set. That's your answer. Of course, it wouldn't be a good day if we didn't have a word problem. So, a lookout on a submarine is h feet above the surface of the water. The greatest distance in miles that the lookout can see on a clear day is given by the square root of the quantity h multiplied by 3 halves. That means our equation is d equals the square root of 3 halves times the height. We've got a square root function, no problem. The domain, remember, underneath there can't be negative, so 3 halves h has to be greater than or equal to 0. get h by itself, and we realize quickly that h has to be greater than or equal to 0. That's our domain, no problem. Now, through the magic of flipping the classroom, we have our x and y table, our height and distance table already there for us. I've just entered things in and calculated, no problem. So we can go ahead and graph these. 0, 0, 1, 1.2, 2, 1.7, 3, 2.1, 4, 2.4, 5, 2.7, 6, 3, 7, 3.2. That starting ordered pair is our armpit, and then we're stretching out over that way. We can easily find the range by looking at that top value. We know that distance deals with 0, and all the values in that column are greater than 0, so we have greater than or equal to 0. No problem. We've just done them like we did the last two. For part B, a ship is 3 miles from a submarine. How high would the submarine have to raise its periscope in order to see the ship? This tells us that distance is 3 miles. This is like our h-axis. This is our d-axis or distance axis. So we think, where is distance equal to 3? If we go along over here, we find that it's equal to exactly 3 right here at 6. We could have figured that out from the table as well. So how high will it have to raise? That would be 6 feet. Here's your assignment for today. Bring any questions you have tomorrow to class, and we'll see you then.